Have you ever pondered on the enigmatic question, can something be two things at once? Can a simple object be both a particle and a wave? If you think it's impossible, then you haven't met the electron yet. The electron, a fundamental particle of the universe, exhibits a peculiar characteristic known as the dual nature. This suggests that it can behave both as a particle and as a wave. If it sounds confusing, don't worry. Even the brightest minds in physics were taken aback by this unusual property. So what does it mean when we say an electron has a dual nature? Well, when we talk about particles, we imagine tiny balls of matter, like a minuscule marble. Electrons, when behaving as particles, fit this description. They can move from one place to another, they can collide with other particles, and they can cause a ripple effect in their environment. However, electrons don't always follow the rules set for particles. Sometimes they behave like waves. Imagine tossing a pebble into a pond and watching the ripples spread out. That's how electrons behave in certain conditions. They spread out, they interfere with each other, and create patterns just like waves. This wave-particle duality of electrons was first proposed by French physicist Louis de Broglie in the early 20th century. It has since been experimentally confirmed by numerous experiments, most notably the double-slit experiment. The double-slit experiment revealed that when electrons are fired at a barrier with two slits, they don't just pass through one slit or the other, like particles would. Instead, they create an interference pattern on the other side, as if they've passed through both slits simultaneously like a wave. This experiment vividly illustrates the dual nature of electrons. Now, you might wonder, how can an electron be both a particle and a wave at the same time? It's a question that has puzzled scientists for a century. The answer lies in the realm of quantum mechanics, a branch of physics that deals with the behavior of particles at the atomic and subatomic level. Quantum mechanics tells us that the properties of particles, such as their position and momentum, are not fixed until they are measured or observed. Until then, they exist in a state of superposition, where they can be in all possible states at once. So, an electron can be both a particle and a wave until we look at it. To wrap up, the dual nature of electrons is a fascinating phenomenon that challenges our everyday understanding of the world. It shows us that electrons, and indeed all particles, can be both particles and waves. They can exist in multiple states at once, and their behavior is determined by the act of measurement. This is not just a quirky feature of the quantum world, but a fundamental principle that underpins the very fabric of the universe.